Hi. Today we'll be going over exponent rules, or properties of exponents that show up often in a variety of problems. These are properties of exponents that are really useful, can help us simplify problems and use exponents in a variety of contexts. And they're based on observations we make by seeing how exponents behave. We're going to start with the power rule. So let's start up with an example of this rule to see why we even have it in the first place. Say I'm doing something like 3 to the 4, right? That's 3 times 3 times 3 times 3. But that's also 9 times 9, since 3 to the 3 times 3 to the 3 is 9. So we could say that's equal to 3 squared times 3 squared. Well, 3 squared times 3 squared, that's 3 squared multiplied by itself. So we could say that's equal to 3 squared squared, right? This is just this times itself, right? If we were to say, okay, 3 squared is a, we'd have something like a times a, which would, of course, be a squared. But we notice, hey, 3 to the 4 is equal to 3 squared squared. If we were to multiply these two things, both outside and inside the parentheses, we would get 4. And that's what the power rule is. The power rule says, hey, if you have some number a, some base a that you're doing all this multiplication with, you have a to the m times a to the n. A to the m to the n, right? That's the same as a to the m times n, right? So if I had 4 to the 3 to the 2, that's the same as 4 to the 12, right? If we had 6 to the 3 to the 3, it's the same thing as 6 to the 9. And that is the power rule. Next big one we're going to talk about is the quotient rule. And for this, I'm going to start with a problem example, right? Let's say they ask us to, divide, let's say, x to the 7 by x to the 4. So we can rewrite that as a fraction, right? X to the 7 over x to the 4. That's how we can do. Now, as a fraction, what we really have is x times x times x, a whole bunch of x's until we have 7 x's on one side, right? And then x times x, and then a whole bunch of x's until we have 4 x's multiplied together on the bottom side. Well, now the one thing we know about fractions is that we can cancel out terms from the entire thing, right? We can cancel out this x and this x. We can cancel all the x's on the bottom, so we're only left with x's on the top. So we have 4 x's on the bottom. So we can take x to the 7 and we can cancel out 4 x's. That'll leave us with 3 x's left, or x to the 3. But we notice this new number is the same thing as x to the 7. It's the same thing as this number subtracted from this number, right? 7 minus 4 equals 3. So we can take that, formulate another rule or law based on that. And I'm going to keep using a, m, and n as an example, right? If we have a to the m divided by a to the n, that's the same thing as a to the m minus n. Now that's particularly interesting, because what happens if, say, n is greater than m, right? That would mean that we'd be raising a to a negative power. What does that mean? What does that mean? Well, let's use an example, right? Let's say, okay, x to the 3 over x to the 5. The quotient rule tells us that's the same thing as x to the 3 minus 5 or x to the negative 2. Right? That's really interesting. But we notice x to the negative 2 is the same thing as whatever this is. So we're going to simplify this. And so we can cancel out all the x times x times x on the bottom, on the top, the numerator. We can cancel out these three x's, and we're left with 1 over x squared. So, in short, what we have is 1 over x squared equals x to the negative 2. Now what that really says is, hey, when I have a negative in my exponent, I'm really just taking whatever I have, let's say x squared, and I'm flipping it, right? So my rule is, if I have, a to the negative m, that's the same thing as 1 over a to the m. And that's another rule that we can see, right? So when we have a negative exponent, we're going to flip it and do 1 over a raised to the positive version of that exponent. That's all we have to do. Now, let's do the product rule. And this is something we kind of already touched on, but it's nice to formalize it, make it really clear, because it's super, super helpful. Let's say we're multiplying, x to the 3 times x to the 5, right? That's x times 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 x, right? 1, 2, 3, 4, 5. 5 x's times 3 x's, right? So, and all told, that's x to the 8. We notice, hey, this 8 is the same thing as this plus this, right? When we multiply two exponents of the same base, our answer will just be what we would get if we added their exponents. So we can make a rule out of this, right? If we have a to the m times a to the n, it's the same thing as a to the m plus n, right? So here we have it. Multiplying exponents with the same base is the same thing as adding their exponents, right? Remember, that's different from the power rule, right? If they're in parentheses, we're going to multiply the exponents. But if they're not in parentheses and we're just multiplying the terms themselves, we're going to add the exponents, right? So parentheses, multiply. No parentheses, we're just regular multiplying, we're going to add, right? But what about when we have something to the 0 power, right? Let's say we have, 5 to the 0. What is that going to be? Well, we can go back to the quotient rule. We can say, okay, let's say we have x to the 3 over x to the 3. Quotient rule tells us 3 minus 3, that's x to the 0. But these terms, they can cancel out each other. So we're left with 1. So if we have any value raised to any power, to any 0 power, it's going to be 1, right? 5 to the 3 over 5 to the 3 is 1, which is also 5 to the 3, which is also 5 to the 3 minus 3, or 5 to the 0, right? So we can say, we want to formalize it, a to the 0 equals 1. And those are the basics of exponent rules. So let's cover about every rule, every property that are involved in the basics of exponents, and they help formalize it and make it useful, right? And just remember to keep those in mind. Like, hey, if I'm dividing exponents, I want to make sure, hey, I subtract the exponents, right? Numerator minus denominator. Or hey, I have exponents in parentheses, all right? I'm going to multiply them. Oh, I have a negative exponent. That's the same thing as 1 over that power raised to that positive exponent. An important thing to keep in mind, though, is that most of these only work if the base, right, the value that you're raising to the exponent, is the same, right? And here, those both have to be a. those both have to be a, right? We can't have something like, oh, 3 to the 6 over 4 to the 2. Okay, well that's just 6 minus 2. Okay, that's 3 to the 4. We can't do that. Those bases are not the same, so we cannot use them. So we can only use these things if the bases are the same. If they're not the same, we can't use them. Hands back. All right. That just about does it. I hope that was helpful for you, and I hope you have a great day.